Hello everybody, welcome back to my garage. This is Josh 55210 on YouTube here, and time for another update. Last time I left you guys, I just got the trunk or the main floor slid underneath the car. Hadn't got anything welded up yet. I wanted to start tackling welding this thing in right away, but I caught a nasty cold. Like, couldn't breathe, throat burning, all that kind of fun stuff. Took I don't know, 3 or 4 COVID tests, all passed negative, so it's just a cold, something I haven't caught in the last couple of years because everybody's been staying away from each other. Haven't been going out a lot, so yeah, things start to get back to normal, and unfortunately normal's catching the other upper respiratory infections that go around. But started to clear out of that a few days ago. Came out and wanted to give a little test on how I'd handle, welding and such with the nose all clear or stuffy and everything, but doing okay. So what I've got so far here on the passenger side, I've got the upper flange for the floor tacked and welded into the rocker panel. So I've got some upper tacks that I did kind of in between to hold everything together, and then I actually have what was the holes that I punched, I welded up. So for these I used the TIG welder because it welded really cleanly to this weld through primer that the rockers came in. Did pretty nice. And then where the metal was a little junkier back here, I used the wire feed. I still want to knock some of that down and clean it back up. Gets a little stronger weld. I haven't done the bottom side where the flange points down here at the wheel tub, but I did get across on the top side where the floor meets up with the trunk floor. Got that burned in pretty well. So what I'm going to work on today is getting the driver's side done up similar to what I did on the passenger side. Probably use the TIG on the rocker panel is my plan, and then when I get back to this back portion I'll kind of see what I want to do, because on the driver's side over here I had put that patch to replace the rotted out portion of that inner quarter panel area. So this has all new metal here, so all I got to do is just kind of pinch that together to pull it together. Height wise lined up pretty good. On the passenger side, the body's wanting to sit down a little lower than the floor did when I had all the bushings in place, and so I went to go jack up just the rocker panel a little bit to level it out, and it wasn't really lifting it the way I wanted. So I actually put the jack where the helmet is with some pads so it wouldn't dent up the floor, and I used the brace to lift up, so it actually lifted up behind the door and get the rocker panel on the flange over there to mate up with the flange on the floor nice and even. That worked pretty well. Just used the jack and it squeezed everything apart, so it pushed the floor down and that bar up rather than just lifting up on the body, because that was where it had contact and was dragging a little bit on the flange on the far side. That was wanting to raise everything up. So got that done. This side mates up together pretty well. Got my little collection of clamps and stuff out. I just want to pinch these together and get going on the welding there. And one little shop update while before I get going here. I've insulated the shop and everything, and right now it's showing just about 60 degrees in here, and it's been that way for the last week. So we had a nice warm week, and I had that cold, so I couldn't get out here and get anything done. I was really frustrated. But then when I start to get feeling better, the temperatures drop back down again. But I had a family member that had this old DeLonghi oil heater that they weren't going to use anymore, so they gave that to me for free. So instead of running propane and burning stuff out here and worrying about carbon monoxide, I now have the little electric heater, and I had that thing set for 60 degrees, and it's holding that with the insulation, so that's fantastic to be comfortable out here, because just with either extreme heat or extreme cold, like in the winter or the middle of summer, I just don't get a lot of progress done. There are those who kind of tough it out, and I try to, and got the like propane heater out and everything, but it costs so much for the fuel, and it's just a pain, you know, and you're laying on the floor, and if the shop gets really cold, then the floor acts as a heat sink, but a cold sink. So you're laying on the floor, and then 6 inches up from it's just a layer of just frigid air. So if I'm working underneath the car, you're uncomfortable. So anyway, pretty excited about how all that's been working out as far as maintaining the comfortable conditions out here. The environment's pretty nice, so very happy with that. Oh, did have a sad moment last week when I went to go drain the water from my air compressor. Last time I used it and fired it up, the drain was clogged up, so I go to try and unscrew and open it on the bottom of the tank, and it didn't do anything. It didn't even blow out the pressure out of it, much less blowing the water out. And I drained the pressure off with the pressure valve up top, you know, then unscrewed the drain valve from the bottom, and when I pulled that thing out, there was like a layer of almost mud above it, just rust that had fallen down and mixed in with the water and everything. And when I had leaned the tank over to get to that plug to pull it, it sounded like you'd thrown a handful of bolts or screws or something in there. You just hear the rust sliding on the metal. So I got that out and kind of shined the flashlight in there and looked, and it was, the rust was spalling off on the inside pretty bad. So it was like a 33 gallon, I think, Craftsman air compressor that I got 20 years ago as a wonderful Christmas present. But finally just kind of decided to retire that thing with the amount of rust that was going on. I didn't feel safe with it. So next shop project coming up is a bigger air compressor. Get out here something that can handle a little better the air tools I was using. You know, I'd use that palm sander or try and use an air cutoff wheel, and that's partly why I got the Milwaukee tools that I use, is because it works just like a die grinder, but it doesn't use the air that my electric die grinders do, because I just didn't have the reliable air supply. That 120 volt motor, it did really well for what it was like designed to do. So if I was running like a framing nailer or something, it worked just fine. But anything like that that has really high CFM consumption, it would drain the tank in about 30 seconds, and then the motor couldn't keep up enough input to run the tool and pump the tank up at the same time. It would just run down and down and down. So use the tool for 30 to 90 seconds and then have to stop and wait 2 or 3 minutes for it to recharge, and just do that cycle over and over again. So I'm kind of sick of that, so I'm going to get a 240 volt outlet put in out here and step it up to a bigger tank, bigger compressor. Don't have one picked out just yet, still kind of shopping for that, but definitely going to beef that up and have a better air supply out here so I can get a lot more work done, especially when I start painting or priming and painting on the car. Definitely need something with a little better air supply and filtration and all that. So yeah, do plan on doing my own painting on that one, and we'll be learning along together because I haven't painted a car before. So, but worst comes to worst, you sand it off and have someone paint it again. So anyway, give it a try and see if I can't learn how to do it and get it to work out. You take your time, and as long as you pay attention and do your homework, you can do just about anything you want with cars. Like if you don't have the experience with welding, get a welder, go to a friend's house who's got one, get some material and practice. You can work on engines. You know, you can do a lot because there's so much information out here on YouTube and just out there. You know, the internet's a fantastic thing as far as information sharing and skill sharing, especially YouTube. Like I picked up how to sew upholstery, picked up how to do knit and crochet when I was in college just by watching YouTube videos. It's just a fantastic place to pick up and learn new skills. I had never been really good at catching catfish at all. I always struggled. Watched videos over a winter break. Got really educated on kind of the things I was doing wrong, trying to transfer what I knew about bass fishing over into catfishing, and learned a lot of things over that time frame when I was watching the videos. Then come that next spring, I started catching the heck out of them, and big. Went from going out, 2 or 3 days for maybe 4 or 5 hours at a time after work and maybe catching one fish out all those days to getting out on the river and catching 15, 20 catfish in an evening. I hadn't gone deer hunting until 2015, and when I started to get into it, I watched a lot of videos about setups and just do a lot of research, and the information's out there. And I started getting them, 1 in a season, then 2, then 4. It's amazing the tool that this is. But anyway, I'll stop blathering on, get this thing set up, and we'll get going on the welding. So stick with me, and thanks for putting up with some of the rambling rant, and we'll get to work here. Alright, so I've got the first bit of the welds done. What I've done is touched on just the upper portion of the flange, just to bond the two flanges together. So one of the reasons why I really like the TIG is you can see, compared to my fingernail there, just how fine of a weld that is. Very small. I'm actually using a very thin filler rod on here. I think 045. Let's have a look. Yeah, ER70S-2 and a 045 diameter, 0.045 inches. So very thin material, close to the material thickness of the panel. Actually, I believe this replacement panel is actually closer to 60 thousandths of an inch thick on each side. So this is 120 thousandths or an eighth of an inch when the two flanges are stacked together. I could grab some calipers and look at it, but anyway, very thin stuff if I do need to do anything. But all I'm doing is with this tungsten on the TIG, I have a gas lens set up on it so you can have a little more stick out. It makes the gas flow more stable as it comes out of the cup. It allows you to have a little further stick out on your electrode, which I like. But I just get in here, press down the pedal to initiate the arc, and I'll watch the two pieces of metal flow together. And on these edges, you can generally get by just moving steadily, and it'll fuse the two together. It's called an autogenous weld, but sometimes you hear it just say fusion weld, but fillerless weld. And then I'll occasionally dip the filler into it just enough to maintain the level, because sometimes as you get going along, that edge starts to dip down and go down and just kind of cut and dig in. And I just add enough filler to bring the top of the weld puddle back at the same level as the rest of this stuff, so it just doesn't dig down and cut in. But yeah, I put tacks along just to keep it together, because like, even though they were butted together pretty nicely up here, you saw how I've got it kind of clamped together with this flanging pliers to squeeze those flanges and hold them at the center section. But even if they're touching and they look nice, if you don't put a clamp next to it, you start welding on it, it gets the heat here, and those two panels will just separate from each other. You'll get a bulge inward on this inward side, and you get a bulge outward and a big gap, and I want to keep everything nice and tight. So gone through initially and just put all those tacks along the top. And what I'm going to do next is to go back on all these little spots that I've hole punched and fill them up with weld. And it's with this TIG, it's not getting all the way into the base metal on this side. So I've got the hole punched on the black sheet metal. The silver doesn't have a hole. Something you can do is drill matching holes and then use a copper backing bar, and when you weld you'll fill up through both thicknesses of metal, and it'll join really nicely. What I'm going to do here is, and I discovered it when working on the other side, it wasn't getting quite as much bite into the rocker panel as I wanted it to. Just filling the hole up, because with the hole being as small as it is, the filler metal will fill the hole and not actually penetrate as far down into the next piece of sheet metal. So what I've done, and I did it over there, and what I plan on doing over here, is when I get in here, I kind of start on the bottom side with the TIG and with the filler, and I fill it from bottom and work my way up to the top, and it fills this hole over. And then once I've got the hole completely filled up, what I do is just rest the tungsten on that spot, and I've got my machine set to 100 amps, which is really high. Welding this sheet metal, you can do it somewhere between 45 and 60 amps depending, and you'd be just fine leaving it there. And that's what I do with the pedal. I've got it just start to get on it just a little bit, and I've got the machine turned off right now. But you can go all the way down. That's 100 amps. But I'm usually just touching just enough to maintain the arc, and I'm hovering in the 50 to 60 amp range. And then anyway, when I get the hole filled in, I'll hold this right on the center of it and ramp it up to 100 amps for a moment. And what you'll watch, which you won't be able to see here because I don't have a setup for a welding lens for the camera, unfortunately, but I'll describe what's going on. You've got the dome of the filler metal that is covering over the hole. And when I put the TIG torch directly on the center and crank it to 100 amps, it melts the center section and causes it to suck in. And when it does that, it's melting the whole area and actually causing it to penetrate into the next side. So I can go over to the other side and kind of show what that looks like, what it looked like on the other piece of sheet metal. Work my way around here. So when it melts through, one way you can tell, you've got the heat affected zone that you can see, but you can actually see it looks like I've welded it on this side, but the heat is such that it's melted and pulled that filler metal through, and it starts to bulge out on the other side because it actually has made both sides liquid. And then I ramp off of it. It's kind of simulating what a resistance spot weld would do, but I don't have a spot welder. So you can also do it with the wire feed weld. I've said it before, like when I did this lower pillar weld portion, I like the control of a TIG welder, and that's what I did for a living for 5 years, essentially, was TIG weld. So I feel most comfortable with it. I do wire feed weld. This is wire welded, that's TIG welded. This front section was TIG welded, that was wire welded. I kind of alternate back and forth, but the TIG doesn't throw as much smoke, and now that I've got everything sealed up, I no longer have the open soffits for air ventilation blowing through. I want to keep it as less smoky in here as I possibly can. TIG allows me to do that. That's why I'm doing it. Now, you can do the exact same things with the wire feed weld, and if filling in these holes with a wire welder, what I would do is when I start the weld, when starting the weld, I would point the filler and the torch at the bottom of the hole, and then make a circle around to fill up the hole. I'd actually make it larger than the size of the hole as well than what this punch does. This punch does, let's see if the old information here says the size of it. I can't even remember if it does. Something like 3/16 or so. I would actually open that up to like a 1/4 inch or even bigger, like ream it out with a drill bit. Because with the wire welder, it fills up the metal so fast that you don't get as much time to penetrate. So a larger hole actually allows you to work your way around and fill up the little rosette. But with the TIG, you don't have to do it quite so much because you can fill it over quick and then burn it in, get it to suck in. But anyway, either way, you have the ability to do it. That's kind of how I recommend going about it, and how I'm doing it on this one is do some tacks along your edge, and I'm gonna actually, I think I'm gonna get in there and tack that backside first, and then I'll come back and start burning in all those heavier ones to really get the meat of the flange. Because if you just do this upper side, it would probably hold as well as if you did it on the bottom side like this, 1/4 to 1/2 inch long welds. That would hold okay, but I really want this thing like bonded how it was originally intended, with those resistant spot welds, where instead of it just being up here on the surface, it's actually bonded into the meat in the middle of the flange. Because otherwise, if you don't, then if you have any forces that tend to separate the body from the rocker in this manner, it can fatigue that tip off, at the end. But if it's bonded in the middle, it really can't pull it out. So anyway, I'll get this time lapse set up again, and I'll finish tacking up the other side. Actually, I think I'll leave the time lapse off for that one. I'll get the backside topped off, and then I'll turn it back on whenever I get going for the meat of those rosette welds. So stick with it. right. Figured I'd stop and kind of show you what the different stages of burning in these rosettes for tying the flange in looks like. So, I'm gonna turn this light on. Let's see if we can see kind of the profile of this weld. I don't know if it's coming in as clear as I want, but I'll set that there. So there's quite a hump on this particular piece of weld. Let's see if we're looking straight down on it, we'll kind of get it. Hope it focuses, but there's quite the peak there on the hump. So, and on this side, you can see that there's a heat affected zone, but it's kind of small. And if you look at these two that I just did, you can not only see the heat affected zone, but you can actually see where it's melted the metal through on these pieces. So then, I'll try and show what the profile looks here. So these start off with that big hump, but when I really ramped up the weld, it got quite flat right here. So it sucks all that weld metal in and bonds in with this side. So that's what I've been doing, just kind of burn it in, and you can see it's melted on this side. You've got a really strong bond, basically close to the diameter of the heat affected zone there. It really ties in. But yeah, so this one doesn't have the bond quite yet that I want over onto this side. So let's see if I can't get this set up. We'll see if I can get it where you guys can see it. Doing this real time and didn't quite plan ahead, so head along with me while I try and figure this one out. Maybe I can set up my spare helmet here. Okay, it's on. Just see what we can do. That. Bring this other lamp over. Alright. Stick with me for a second while I try and get this set up. Okay. Good. This thing clamped somehow so it can point down there. Once again, thanks for holding on live for me, everybody. While I get this figured out, I'll run a little test and see how this goes. See where I'm pointing. Right into the back of the welding helmet. I'm going to turn off this backlight and then we'll see. Now when I turn on the welder, it's going to turn the fan on. It's going to get kind of noisy, but I will make an attempt to narrate what I'm doing. Okay. Try not to knock the helmet out of the way, and hopefully you guys can see what I'm doing. And I think I'm going to do it left-handed so I'll be out of the way here. So The first thing I'm going to do is establish the arc. So right now I just have it on, but I'm only at maybe 15 or 20 amps. So I'm going to rock my foot pedal and get it up to about 100, and the weld metal just flattened out, and then I'm resting at a lower one to let it solidify, let off completely, and hold the torch in place for a few seconds until that red goes away. And that is all it takes really to burn it in. I can see from this side that the metal looks melted on this other side of that sheet metal flange, and it's a good burn-in. So now that that rosette is tying into both pieces of sheet metal, and it's plenty strong. I'll get this set back up here for time lapse for the rest of it, and get back with you afterwards. Thanks. Well, hopefully that was informative for everybody. Seeing a little bit different way of doing sheet metal work on the body of a car. And so much of what you see online is usually just using wire feed welders because it's convenient, and I enjoy doing it too. But I'd like to show a little bit of variety, and even though this is not the fastest way of doing it, it's one that I enjoy. So I wanted to share with everyone. On one of these, I actually did get a little more carried away with the melting I did on this side, and maybe you can see I've got the bump now burned through on this side. So definitely know for sure that that one is burned in and attached pretty well because it made the same weld profile on the other side. That's not exactly what I'm going for, but all I can, if there's any issues, all I got to do is just kind of dress that down real quick with the roll-lock disc or the grinder or whatever, and make it flush, and it'll be good to go. But I think that's all I got going for today. I'm going to finish up the last little back edge back here. The orientation that I've got to get into with my body to get that will make it where it'll be pretty hard to have the camera angle where you can see it, but it's just the same process that I did along the rocker panel. Just go around the hole, filling it with filler metal to get the hole completely closed up, and then cranking up on the heat and melting that weld bulge into a more flush profile, and binding the two pieces together. I'll be hitting that around. I think the next video will be me getting the flange on the bottom side of the rocker and the floor. And my plan is for the video after that, we'll be working on replacing the rotten portions here in the toe boards. And then once that's done, plan on picking the whole body off the frame and get going on that. So it's starting to warm up this spring. I'll be able to roll this stuff outside, like the frame for stripping and cleaning that thing off. And hopefully I'll have the new air compressor and air supply set up for that, because I want to paint the frame and not just brush it or roll it on. I'd like to use my sprayer. So anyway, stay tuned. We've got a few things coming up planned that I think will be pretty neat. So thanks everybody for watching, and if you enjoyed it or got some value, some information, or even just entertainment out of the video, maybe give it a thumbs up, like there, and subscribe if you haven't. Catch everyone later. Thanks.